Hey guys, welcome back. This is Professor Roldan again. This is section 2.4 and 2.5. Both sections have to do with Venn diagrams with three sets. Okay? And so you've seen what two sets look like. So what about three subsets of the universal set? All right, well, it takes a little used to drawing, but here we go. Nice little, make sure you make a nice rectangle so you have ample space to write three circles. So the first two circles are going to be like the ones we've done in the previous section, up near the top. Okay, left, right. Okay, so far so good. Then we do another one at the bottom. Okay, so the universal set is the same. It's the whole entire rectangle or box. And then we have set A, set B, and set C. So this creates not 4 regions, but this time it creates 8. Okay? So you're just going to start at the top left and go straight across. So set 1, set 2, region 1, region 2, region 3, region region 4, region 5, and that's the center, region 6, region 7, and region 8. Okay, so there you have it. That is Venn diagram with 3 sets, and I just want to quickly read from page 70. Mathematics Today. It talks about a financial planning company, uses this Venn diagram to illustrate the financial planning services it offers. So it offers 3 products. From the diagram, we can see that this company offers advice in an intersection of the areas of three things: investment, retirement, and college planning, and the intersection of all 3 sets. And then it talks about how we categorize items on a daily basis. Children are taught how to recognize items at an early age when they learn how to classify items according to color, shape, and size. Okay, 3 sets. And then we already mentioned the biologists who categorize items when they classify organisms at the beginning of this chapter. So this is a very useful tool to help visualize, order, and arrange items, to picture the relationships between these sets. Hopefully you'll be able to use this in your studies, in other classes, and impress your professor. All right, so here we go. You're welcome. All right, so we have number 1. It says construct a Venn diagram given the following information. So there you have the universal set U, which is 1 through 13. And then you have the subsets A, B, and C, which have various numbers in it. Okay. So we need all the room we can on the left side for a big Venn diagram, so we can see things clearly. So we're gonna need some room on the left, and let's see, that looks pretty good. Then make your 2 circles at the top, 1 at the bottom. Okay, this is U, this is A, this is B, and C. So what we want to do is start with the center and work outward. Okay. Start with the center, just like we did with 2 sets. It's the intersection of both sets. In this case, is intersection of all sets, all three sets. Okay, work outward from there. Okay, now I'll give you a little bit of tips as we go along. So, number one, the center. Okay, that is the intersection of all three sets. In set notation, that is set A, intersection with B, intersection with C. Okay, and that is region 5. Okay, region 5. That's right in the center. So how do we start with that? Well, that you have to look for what all three sets have in common. Okay, so take a look. All three sets, I see a 9 right there and a 5 right here. So those two numbers are going to go in the middle. Okay, next you do actually, so let me just yeah, I don't have room for that. So okay, let's move on. Number 2, it's the petals. Okay, okay, so the petals, the top petal is basically A intersection B. Those are the top two circles. Okay, and that is the result of region 5, which is in the center, plus region 2. Okay, and we can look up here to reference the regions. Okay, so then the next thing, make some more room here. Intersection of B and C, which is right here on the right petal, and that's region 5 and region 6. Okay, and then intersection of C, or A and C, I should say. It's also region 5 plus region 4. And that is right here. Okay, so it looks like petals of a flower. And let's go ahead and do the first one. Okay, so A intersection B. Now A intersection B is basically, what do A and B have in common? And we already have two numbers in common, 5 and 9. That's in the center. So we're not going to rewrite those. We're going to see if there's anything else in common. And yes, I see a 10. Okay, so that 10 is going to go in here. Okay, so we have three numbers, 5, 9, and 10 between A and B, and there they are. 5 and 9 in the center, 10 up at the top. Okay, because 10 is only between A and B, not between all three. Then we're going to go to intersection of B and C, which is the right petal. And if you look at the list, B and C is the bottom two rows, and I don't see anything else in common besides 5 and 9, which we already have written in the center. So there's going to be, so region 6 is going to be blank. That right petal is blank. Let's go to intersection of A and C. That's the left petal. And the left petal, as you can see, from the list, you got A and C have a 1 also in common, and an 8. So those two sets have 4 numbers in common: the 5 and the 9 that we already have written, plus the 1 and the 8, okay, that they also have in common, only between A and C. All right. So again, we started with the center, working our way outward. Now we need to do the exclusive parts. And basically, in set notation, the exclusive parts will be set what's only in A, but not in B or C, or B and C. Okay, only in A. So that will be region 1. Okay, region 1. All right, so let's take a look at region 1. Region 1 is only in A, so if you look at the list for A, this makes it nice and easy, because if you look at A, the only number not highlighted was this one right there. So that is exclusive to A, and that goes nice and neat right there. Now we have we go to the next one. What's exclusive to B? So it's in B, not in A, and not in C. And that is region 3. Okay, and if you go to B, B has 2 numbers that no one else shared with it. So 2 and 4 will go up here. Then we have the next one, which is only in C and not in A, or not, and also not in C. So if you look down at C, the exclusive region is 7. And all we're going to do is go to our list and say, hey, there's the 11 and a 3 that no one else circled, so that means it's exclusive to C. Okay, and then our last one will be region 8, which is basically outside all sets, but still in U. Okay, so if you look at all that, it's basically in set notation, it's the union of A, B, C, and everything not in that. So that's region 8. Oops. So let me get a different color, which is going to be black. Region 8. So region 8, how do we get region 8? Well, if you look at our sets, it's those things in the universal set not already in those other 3 sets. So we can just go to our list and count off, okay? And we can say, hey, we have a 1 in set A and C. We have a 2 in set B, 3 in set C, 4 in set B, 5 in all 3 sets, 6. Where's the 6? I don't see a 6 anywhere in the list or in the circle. So 6 is part of U only. Goes down there. 7, is there a 7? Nope, no 7. Okay. And we keep going. There's an 8 already listed, 9, 10, 11, 12, and now I don't see a 13 in the list or in the circle, so 13 is also in U and not in the other 3. Okay, so this is how you fill out a Venn diagram with 3 sets. Okay, so now we're going to do sort of an application question where it's a word problem, and we're just going to list the regions, okay? We don't have to fill out the diagram, it's already kind of done. So we just say, okay, what group are these senators going to be in if they voted yes for a certain bill? So I would say the easiest one to start with would be if they all voted yes. That goes in the center. So if you look right there, they all voted yes. So that is region 5 or group 5. Okay? And then the other easy one would be, hey, what if they all voted no? That means they would not be in any of the circles. So there's all the straight no's. And that is outside all 3 circles. That is region 8. Okay? So that's where I would start. And then I would go to one yes. One yes signifies exclusivity. So like this yes right here, that's only for Bill 1. So that's definitely exclusive to set A, which would be Bill 1. So that's region 1. This is exclusive to set C. That's region 7. This one's exclusive to set B, which is 7. Wait. Sorry, that's 3. And then these two are in both set 2 and 3, or bill set B and C, which is going to be group 6. Okay, so that's how you kind of work through that. All right, now let's take a look at number 3. And number 3 is basically everything's filled out. You just got to figure out how to read the question and where to look. So the intersection of A and B for A would be right here. So the answer is C and D. Okay. This is supposed to say C complements union A. Not sure what happened to that. So basically everything outside of C. So here's C. So you can't look in there. It's outside of that. And if you unite that or union with A, well, A already has. So there's the answer right there. So A, B, C, and H. Okay. Let me go ahead and erase that. Okay, how about the union of A, B, and C? That's basically all the circles, guys. That's all the elements in there. So all 3 sets, remember, no repeats. So all 3, no repeats. Okay. So all you gotta do is just list as you read. So I'm gonna do it in ABC, alphabetical order. So A, B, C. There's D. There's E. There's F. There's G. There's H. Down at the bottom, there's I and J. Okay, that's it. Then we have the intersection of A, B, and C. Guys, that is, if you haven't figured that out by now, that is the center. So that is just set D. And then the last one is the union of A and B. Okay, so that's everything in this area right here. That's A and B. Wait, I forgot to erase the previous. Okay. So that's the union of A and B, all those right there. But it says the complement of that. Okay, the complement is what's outside. So those two, okay, so that is I and J. Intersection with C. Well, C is already I with a bunch of other stuff there. So what's in common with C is I and J itself. Okay, so it's pretty straightforward. Or let me just go ahead and break this down a little bit more. So you could do it this way as well. I'm just listing as I read. E, D, F, G, I, and J. And that's what they have in common. So the final answer is I and J. Now you don't have to do all these extra steps. This is just to break it down if you need more clarification. Okay, the last section in 2.4 is verifying statements to see if they are equal, okay, or true. And so what we want to do, has to do with two sets. So we're going back to the idea of two sets. So if you remember, two sets have 4 regions: 1, 2, 3, and 4. So to verify if these two statements are true, we're going to go ahead and list the regions. So set A is 1 and 2. Uh-oh. Let's see. Okay. So region set A is 1 and 2, union with set B, which is 2 and 3. So remember, that is all those but no repeats. So we're not going to repeat region 2 in the center. Okay, and all that complement. So all that means is everything outside those 3, and that's going to be region 4. Okay, now we're going to see if we get the same thing on the right side. So the right side, okay, so A, we already said is 1 and 2. B is 2 and 3. Okay, and both of those are complements. Whoops, sorry. Let me just write this. Parentheses. All right, so now we're going to write down what's not in 1 and 2. Basically 3 and 4, right? And what's not in 2 and 3, which is 1 and 4. Okay. And why do I have an equal sign? I do not know. I'm supposed to have a union sign. So the union is to write down all those except do not repeat. So we have 1, 2, there's no 2, there's a 3. And then there's 2 4s, so we're going to write it once. So guys, this does not equal. Okay? This is not equal. Or you can say it's basically false. Okay? Now, go ahead and try the next one on your own and see what you get. And I'll see you in a few minutes. Go ahead and pause the video and try it on your own. Okay, so you should have gotten true. How did I get true? And you can skip some of these steps, especially the first line that I have written. That's basically just kind of breaking it down, but you could probably figure that out using other clues and just looking at the diagram, whatnot. But this is kind of the step-by-step process, and these two statements are true. So guys, basically what we've just done is you proved one of De Morgan's laws, okay? De Morgan's laws for sets, you can see them on page 70. So page 70, You have De Morgan's laws for sets. And you guys just proved one of them. Okay, so we'll just go ahead and write that one. So it's saying that the union of A and B and the complement of those two, the complement of the union of A and B is the same as A complement intersection B complement. Okay? You just proved those two true. So if you look at how to remember this, we can see that it was almost like we distributed the complement to both the A and B, right? Because they both have it over here. But in order to do that, you have to flip the sign. Or reverse, yeah, flip it. Let's just say flip. Okay, so if you want to distribute from a parentheses, you flip the sign. Actually, I don't recommend doing that when you're trying to figure stuff out, because it's easier to do it with the parentheses. So this is actually better if you are, if you have something, so if you have something like this, and it's like annoying or difficult, well, you can just go ahead and go do this law in reverse. Okay, so you can say, okay, let me get this complement out from both, put it out there, so I only have one complement, but I do have to remember to flip the sign, and it's now a union. Okay, so you can definitely go in reverse, and then the second one is just vice versa. So you start with the intersection and actually do the same thing, distribute, flip the sign, and voila. Okay, so no big deal. Those are called De Morgan's law. You can use this shortcut if you want, which means you're going from here to there to make things a little bit easier. So that is it for 2.4. Now we're going to move into 2.5, which is applying these things to a word problem. All right, guys, so we're back here, and we are going to be doing 2.5. So in this case, we have, if you read this carefully, we have two items, treadmills and stairmasters, which you can see that right here. Okay, and then so we also have the word both. Okay, so this is where you're going to start. This is two sets. Okay, this is two sets, treadmills and stairmasters. All right, so when it says both, that's basically the intersection. So you just want to go ahead and put the 40 right in there. Okay, and then 60 is, now 60, I'm going to write it above the circle because the 60 is the whole entire circle. So don't write the 60 in the exclusive region. You want to write 60 above it to remind you that 60 is the whole circle. You already have 40, which means all you have to do is put 20 to make 60. Okay, now go to the other one. It says that, oops, I'm in the wrong, sorry about that. 60 is supposed to be over here, and 20 is supposed to be over here. All right, so now treadmills, there's 100 treadmills. That's the whole entire circle. Okay, so if you already have 40 listed in the circle, that means you have 60 to make that 100. Okay, now we got to fill in region 4, which is outside. So we know that the total, which is the universal set. So the universal set is 150. Well, we have to subtract all 3 regions, okay? We're going to subtract 60 plus the 40 and the 20. Once you do that, you got region 4. So it's 120, which equals 30. And that's it, okay? So once you fill out the Venn diagram as such, now you can answer the question. So how many did not use either the treadmill or the Stairmaster? Okay, so in a sense, that's like saying, okay, the union of both of those, but outside, and we know that's region 4. Okay, they did not. That's complement. So we're talking about everybody outside the 3 regions. That's region 4. So all you gotta do is say, oh, my diagram says 30. How many use the treadmill but not the Stairmaster? Okay, so basically, how many use the treadmill but not the Stairmaster? Okay, so what's exclusive to T or to treadmills? That's region 1. Okay, region 1 is 60. Okay, that's only for the treadmills, not shared with anyone else. Vice versa for the other question. So in the S circle but not in the T circle, that's exclusive to S. That's region 3, which is 20. Okay. Now, last question. How many used either the treadmill or the Stairmaster but not both? So basically it's exclusive to both. Alright, so what do I mean by that? Basically nothing shared, so that means we're talking about region 1 plus region 3. In other words, the 60 on the left plus the 20 on the right, and that's going to be 80. Okay?